Okay, so let's start section 4.6, substituting into a linear equation. Just to recap, in the last few lessons, we learned how to create an equation of a line from a graph, how to create an equation of a line from a description, and how to create an equation of a line from a table of values. Okay, so today, we are actually going to learn how to solve or how to substitute values into our equation for x and y to solve for the other variable. Okay, and you'll see what I mean by that as this video goes on. Okay, so really quick, just to recall, we can solve for the y coordinate, right? We can solve for the y value in an equation if we know the x coordinate, right? Because we'll be given the rate of change and we're given the initial value in our questions. And then what if we're also given x, right? We can then find what y is going to be that goes with that x, right? So it's the y that corresponds to that x value in a table of values, let's say. All right? Now, we know we can do that. We can solve for y. But what if we're given y and we need to solve for x? Okay, that's the question here. What if we were given the y coordinate in a linear equation, and this time we're asked to solve for the x coordinate? We haven't done that yet. We have solved for y. Like every time we use a table of values, we're basically solving for y, right? We make up the x's, we plug them into our equation or substitute them into our equation, and we get y. But what if now we're given y and we need to find x? The question is, how can we rearrange this formula, this equation here? How can we rearrange it so that x is by itself? So that we get an equation that instead of saying y equals, we get an equation that says x equals. Okay? So that's what we're going to try to first develop in this lesson, and then we're going to try to use that formula after. So what I'm going to show you now is how to develop the formula, how to rearrange this formula, okay, how to rearrange it to get x by itself so that we could potentially solve for x if we were given the y coordinate. Also, remember that you do not need to use x or y in your equations, right? You can use any letters, right? We've seen in the past, we've used C, capital C that represents total cost. We've used that instead of the y value. We've used, let's say, number of people, so like the letter N, for example, to replace our x value. You don't have to use x and y, but let's start with x and y, and as we do some word problems, we'll change it accordingly. Okay, so the next part that I'm going to show you, you do not need to know how to do, but the result of what we do, because I'm going to develop the equation here, the result of it is going to be the equation that you need to use to solve for x. So everything that I finish right now and that I do in this next little portion, you don't really need to know how to do that. You just need to be able to use the formula that I'll get to at the end. Okay? So, remember what I said. My goal here is to rearrange the equation to get x by itself. So that's what it says here. Let's determine an equation that isolates x instead of y in a linear equation. Okay? So let's start with y equals rate of change times x plus initial value. Okay? We need to get x by itself on one side, and that's called isolating x. So here's how you do it. You move the initial value to the left side. So this number right here, you move over to the other side of the equal sign. There's your equal sign there. Okay? There's your equal sign. You want to move it over to the other side. And the way you move it over to the other side of the equal sign is you do the opposite sign, or the opposite in this case of adding. So if it's plus the initial value on this side, to bring it to the other side, you would subtract it. Okay? This is what you end up getting. You get y, and instead of plus initial value, it's minus initial value because we brought it to the other side, equals rate of change times x. So again, remember our goal is to get x by itself, right? So have nothing beside it. Just have x by itself on one side of the equation. Okay, so let's scroll down. Next step is move the rate of change to the other side. Okay, so we're going to move the rate of change to the other side of the equal sign by doing the opposite operation again. And I put division here. The reason why it's divide is because since it's rate of change times x, the opposite of multiplication, to bring it across the equal sign, the opposite of multiplication is division. That's how you bring it over to the other side of the equation. You divide it on the other side. Okay? So you end up getting a final equation that solves for x that looks like this. So remember, you'll be given the initial value, you'll be given the rate of change, and now you'll be given y as well, which will now allow you to solve for x. Okay, so this formula you need to know how to use. We're going to be using that throughout this lesson. So we're going to be using this equation up here. Let's just erase what we have here. Okay, just to clean things up a little bit. We're going to be using this equation here to solve for y when we have x. And we are going to use this equation down here to solve for x when we are given y. All right, so we'll be able to solve for either or. Okay, so let's put a big box around these two equations. Okay, these are the two equations we're going to use throughout this lesson. Okay, so let's start by doing an example. And I'm going to go through the example and do it with the equation, and then we're going to compare it down here to the graph and see how the answers are actually identical. Okay, so we're going to start to make connections and see that the equation is really just the same thing as the graph. It's just a different way of communicating it. Okay, so Jeremy bought a new phone for a cost of $800 and subscribed to a plan that will cost him $75 per month. Okay, $75 per month. Right away, and actually before we even get to all this other stuff, let's write down the information that we know here. We know that the initial value is what? $800. It's the initial value that he paid for the phone. And we know that the rate of change then is going to be, remember, it's always, the rate of change is always usually beside the word per or each or something along those lines. So it's going to be 75. Okay, so just make a note of that. It's $75 per month. That's our rate. Now, let's answer question A. Let's write a linear equation to represent this scenario. So of course, it's going to be in the form of y equals rate of change, and I should write that down here, y equals the rate of change times x plus the initial value. That's how we got this equation down here. Okay, I left y and x the way they are. I replaced the rate of change with 75, and I replaced the initial value with 800. Okay, and we get this equation. But we know now that you don't have to use the letters x and y. We can use any letters we want. So if we come up with letters that are that we can use that make more sense with this equation, I would say that using, instead of y, it looks as though we're calculating like the total cost of what this plan plus the phone will cost Jeremy. So it looks like instead of y equals, we can say that cost equals or c equals. Okay. So, and actually, let's actually write this as C represents cost. And let's do, what should we, well, let's think of what our letter should be instead of x. Remember I said that that letter should always have something to do with, if you look at your rate, look after the word per. After the word per, you see month. Okay, so that means that our x, that's what always our x value is going to represent. It's going to represent months, but it's not going to represent just months. It's going to be the number of months. So let's use the letter M, and let's use that to represent number of months in short form. Okay? So if we were to rewrite this equation, we would get C equals 75 times M times the number of months plus 800. So the total cost equals $75 times the number of months plus 800. Okay, what is his total cost for the phone after 6 months of use? Use your equation. Okay, where do you think you're going to put this number 6? It's asking what is the total cost for the phone after 6 months. Okay, hopefully you guessed it. The 6 is going to replace the M, okay, the number of months. Or, I mean, it's also the X. If you left it as X and Y, then it would be X, okay? We are going to find the total cost or find Y, okay? So find capital C or Y. Remember, they're the same thing. We just can use different letters. Okay, so we're going to substitute in our equation here. I am plugging that 6 in to where M was, right? The number of months was. So we have $75 times 6 months plus 800. Okay, that's a simple calculation. Just make sure you multiply before you add. Follow BEDMAS. You get $1,250. Okay, so the total cost after 6 months will be $1,250 because it's $75 per month times 6 months and then plus the original $800. But now let's get to the new part. Okay, the part we haven't seen before. What if the question was, after how many months will it take Jeremy to have spent $2,000 on his phone? Actually, before we even get to that, I promised that I would look at the graph and show you that our answer's here, and if we look at our answer on the graph, it will be the exact same. So let me go down to my graph. Okay, I just made a quick graph here. This is months down here. I haven't labeled this graph, which isn't proper of me, but here's 6 months right here. Okay, let's look at what the cost is. Okay, it looks like it's bang on 1,250. The benefit of using your equation is, you see how we kind of had to guess where that 1,250 was, right? We kind of had to use our common sense of it being the answer. The equation gets rid of all that guesswork. It actually comes out with an exact answer every single time, 1,250. Okay, that's the beauty of using an equation as opposed to a graph. Okay, so now let's get to question C. After how many months will it take Jeremy to have spent $2,000 on his phone? Okay, so we are now given the cost, right? We were given the cost of $2,000, right? Or given Y, right? C and Y are the same thing. It's saying how many months will it take? So now we don't know M or X, right? They're the same thing. Number of months can be represented by M or X. So now we need the formula that solves for X. We're given Y. We need the formula that solves for X. Okay? So let's write that down over here, what that equation was. It was up here. Okay, so it's this right there. X equals, so I'm just going to write that off to the side here. X equals Y minus my initial value divided by the rate of change. Instead of using X and Y, I'm again here using M and C. Okay, M and C. And now you just plug all your numbers in, right? So you know that the C value is $2,000. So replace C with $2,000. We know that our initial value was given to us in the original question. It's $800. So it's 2,000 minus 800. And we know the rate of change is 75. Plug all those numbers in and you get the answer 16 or 16 months. Okay? You see that? That's how we use this equation to solve for x when we're given y. Okay? And I know it can be confusing because I'm switching letters. I'm going from X and Y to M and C. Try to keep that straight in your head. At the end of the day, if you just use a formula with X and Y, I will not take any marks off. It's all good. Okay? You will still get full marks just using X and Y. I'm just trying to show you the absolute proper way. Okay? And that's to change the letters, but you don't have to change the letters. You can just keep them as X and Y. Okay? All right. Oh, and by the way, let's look at the answer on the graph. Let's look up a cost of $2,000 on our graph, and let's see if we end up getting 16 months. Okay, so let's go to $2,000 up here. Let's go across until we touch our line, and then go down. And sure enough, look at the number that it corresponds with, 16. Okay, so this is just to emphasize that a graph and an equation are the same thing. They're just different ways of representing a linear relationship. Okay, all right, let's do one more example because I know your homework has some of these questions. Okay, so let's go to the top without seeing any of the answers first. Okay, so it says Sarah and Dan rent a hall for their wedding. It will cost them $2,000 for the hall rental, plus an extra $90 per person for food and beverage. Write an equation for the total cost in this scenario and fill in the table below. Okay, so take a second and let all that sink in. The first thing you should always do with these questions is write down what you know. We know that the initial is what? 2,000. And our rate of change then is always going to be the number that is usually beside the word per or the word each or something along those lines. So it's going to be 90. Okay? Now we can answer the first part of this question. The first part of the question is write an equation. We can easily write an equation now. Okay, so let's write an equation right there. So I know that y equals the rate of change times x plus the initial value. Replace the rate of change with 90. Replace the initial value with 2,000. Okay, and then once again, I'm using different letters. Okay, again, you don't have to use these letters. You can just use x and y. But I just want to show you the most proper way. It's my job to do that at the end of the day. Okay, so I replace y with c, and instead of x, I used P that represents number of people, right? Because it's per person, per person. So P doesn't represent persons, it represents the number of people, okay? The number of people. Okay. Now it says that we need to fill in this table. Okay, so let's fill in this table. In the first one, remember, we have the equation, right? We have the equation right here. Okay, so in this first row, we are given, what are we given? We are given P, and we need to find C. Okay, well that's easy enough because our equation already has C by itself on one side of the equation, right? So that's easy enough. So if I go down to my answer here, all you need to do is plug in 150 for P right there, and then solve for C. Okay, so that one's easy. Okay, so try not to look at this side just yet. I'm just going to scribble this off. That's for the next question. Okay, let's look at here. Okay, so we have P. I replaced it with 150. Okay, which was the 150 that's in the table. Remember, follow BEDMAS, 90 times 150 plus 2,000. That's your cost if 150 people came to the wedding. Okay, that is your cost. Now, let's look at the second part of this table. So we can write this number right here. 1, 5, 5, 0, 0. 15,500 goes with 150. Now, let's erase this answer up here. Take a look now. It's a little bit different, right? Now we're given the C value or the Y value, and we need to find X or P. Okay, so we need the other formula. We need to find the formula that solves for X. There it is right there. Okay, and don't forget, I replaced, now again, you don't have to do this, but I replaced X with a P, and I replaced Y with a C. Okay, now you just plug in all your numbers. We know that the C value is given to us. It is 11,000. So I'm just going to write that here, that C equals 11,000, right? We know that the rate of change is 90, and we know that the initial is 2,000. So we're literally just plugging in all these values. So 11,000 for C right there, 2,000 for initial value right there, and 90 for the rate of change. Okay, follow BEDMAS, and actually you can't follow BEDMAS until you clear or simplify what's in the numerator. So just make sure you do 11,000 minus 2,000 first, right? So that's 9,000 divided by 90, which is 100 people. So if your cost was 11,000, or let's just say you have determined that you can only afford spending $11,000, right? In real life, you can only afford to spend $11,000. How many people can you invite with that 11,000? Well, you can invite 100 people. So that answer would come right up here, 100. Okay, so these are real life scenarios that are using linear equations, everyone. All right, so they are used in real life all the time, especially in business, with a lot of